Now we are ready to look at one of Christian's papers where he discusses this approach. Let's jump to the relevant part. Okay, well, it looks a bit complicated, but really it is not. First, we see the CH-SH form of Bell's inequalities, which can be written in terms of the non-commuting bivectors and the filter angles used in EPR experiments, little a and little b. Now, big A and big B describe spins that are far apart. So since we are dealing with local hidden variables, then big A must commute with big B. That is a locality assumption. However, big A does not commute with big A, and big B does not commute with big B. If we were using Bell's scalars, then everything commutes, but not here. Working out the details that I skip, an expression is found in terms of the filter settings, little a and b, for Bell's inequalities. These are the usual vector dot and cross products, and they make the difference by giving the correct value of 2 root 2. Clearly, if those terms did commute, then the answer is what Bell got, 2. The correct answer is 2 root 2 for a spin. Let us look at the filter settings that maximize the square root term. Now it's clear that little a must be perpendicular to a prime, and b must be perpendicular to b prime. So far, so good. We see this in the filter settings that are experimentally found that maximize the CH-SH form of Bell's inequalities. But we can go further. We can write this expression another way using a bit of vector algebra. The only way to choose the angles to maximize the correlation is shown here, and they are exactly the settings found experimentally and indeed from quantum mechanics. Note here that I'm using a spin 1/2 and not the spin 1 of photons. However, we have used no quantum mechanics here, only classical algebraic relationships on a sphere. So let us put it together. Plug in the angles to give the second term of the cross product equal to 1. Christian gets the correct value of 2 root 2 that quantum mechanics predicts and experiments confirm. In addition, the relationship between the filter settings are consistent with the settings that maximize the CH-SH form of Bell's inequalities. Bell's error was to make an incorrect assumption about spin, thinking it can only take 2 real values of +1 and -1, where in fact it can take +1 and -1 anywhere on the surface of a sphere. So now we can understand my earlier statement. Bell's inequalities simply tell us that the correlation between 2 points on a line is different from between 2 points on a sphere, respectively 2 and 2 root 2. I will relate my 2D local hidden variable model to Gerd's and Christian's work and show that spin is fundamentally an enneon.